So you are welcome to Unit 6, Module 2 of Physics 115. This unit presents a projectile motion, a practical example of a motion in 2 dimensions. We are still going to extend the motion treated under 1-dimensional space to this unit, and many of the ideas used previously in the Unit 1, 2, 3, and 4, such as position, velocity, and acceleration, will still be employed. At the end of this video, you should be able to define and list examples of projectile motion, define all the properties of projectile such as time of flight, maximum height, range, and maximum range. You should be able to state the equation for these properties mentioned in this objective. And lastly, you should be able to solve simple problems involving projectile motion. Let's see projectile motion. Let us consider a special case of 2-dimensional motion, that is, a particle moving in a vertical plane with some initial velocity, but its acceleration is always free fall. Acceleration, which is g, which is downward. Such a particle is called a projectile, meaning that it projected or launched, and its motion is called projectile motion. Let us look at that in figure 1 to explain this same projectile motion. Assuming we have this is a 2-dimensional axis, this is x and this is y. Then assuming a particle is kicked from initial position, and this parabola describes the trajectory path of the motion. This is the angle theta with which the particle is kicked. Then we have a maximum height here, which is the total maximum distance the particle attained before falling back to the plane of projection. Now this is the velocity, which is v naught, and this velocity will have 2 components, one along x-axis, let's call that vx, and another component along the y-axis, which is vy. Okay, then the distance between the point of projection of the particle to a point where the particle hits the horizontal plane is called the range. The trajectory of an idealized projectile. We consider a projectile launch with an initial velocity v naught, which can be written as v naught is now equal to v naught, which is equal to square root of vx square plus vy square. So as we have seen, the component of the velocity can be written as vx as a component, which is v naught cos theta, and vy is equal to v naught sin theta. In projectile motion, the horizontal motion and the vertical motion are independent of each other. That is, neither the motion affects the other. Let us look at time of flight. This is the total time taken for the projectile to reach the maximum height and return to the plane of projection. The time of flight is written as t, which is equal to 2 v naught sin theta over g. Now maximum height. The maximum height of the projectile motion can be defined as the maximum vertical height attained by the projectile before returning to the plane of projection. Then mathematically, the maximum height can be stated as H maximum is equal to V naught sin square theta upon 2G. Then horizontal range. The horizontal range is defined as the horizontal distance traveled by the projectile from the point of projection to the point where the projectile hits the plane of projection. The equation for horizontal range can be stated as R equal to V naught square sin 2 theta upon G. Then we can easily define the maximum range. Maximum range occurs when the angle in that range is equal to 45, that is when theta is equal to 45. We can also define that as R maximum, which is equal to V naught square sin 2 theta upon G at theta is equal to 45 degree. So if theta is equal to 45 degree, we have V naught square sin 2 times 45, it is 90 degree upon G, and sin 90 degree is 1. So we can write the maximum range as V naught square upon G. So let us look at example 1. A projectile is fired with initial velocity of 100 meters per second at an angle of 30 degree. 30 degree, not 300. Okay, this is 30 degree. So the horizontal plane. Calculate A, the total time of flight, B, the maximum height, and C, the range of the projectile. Let's look at the solution. It is very simple to solve. All you need to do is to write your formula and substitute then those parameters of velocity and angle there. Solution: A, the time of flight, C, which is equal to 2 V naught sin theta over G. Of course, our V naught is equal to 100 meters per second. Then theta is equal to 30 degree. So we can do that substitution. 2 times 100 times sin 30, then over G, and G is always given as 10. Okay, so carrying out that computation, we have 2 times 100 sin 30 over 10 gives 10 seconds. B, the maximum height, also we state the formula, then substitute our parameter. H max is equal to V naught square, then sin square theta upon 2G. Then by substitution, we have 100 square times sin 30 times another sin 30, okay, then over 2 times 10. This gives us 125 meters. Also, in a similar way, To find the range of the projectile, we use the formula R equal to V naught square sine twice of the theta upon G. By substitution, we have 100 square sine 2 times 30 degree upon 10. So that gives us 100 square sine 60 degree over 10. Carrying out that substitution, and you have 866 meter. So you have seen that the motion in 2 dimensions involves the horizontal component and the vertical component, and you are able to define those properties of the projectile, and you can use the formulas for those properties to solve simple equations. To solve simple problems. Thank you. Till we meet next time.